Hi, good evening, madam. Let me introduce myself to you. My name is Sandeep. I am from mechanical engineering. Today, my topic is about state and prove addition theorem of a probability. State and prove addition theorem on probability. Introduction to probability. Probability is a branch of mathematics that deals with the likelihood of events occurring. It proves a framework of quantifying uncertainty and making predictions. A fundamental concept within the probability is the addition theorem, which helps in calculating the probability of combined events. This is the probability of diagrams, calculators, is the books, formulas, directions, etc. What is the addition theorem? The addition theorem of probability refers the way to find the probability of the union of two or more events. అంటే addition theorem అనేది రెండు కంటే ఎక్కువ ఈవెంట్స్ ఎక్కువ కనుక్కునేది. It state the probability of event A or event B occurring can be expand probability A union B. The theorem is practically useful in scenarios where events may overlap or be mutually exclusive. This is the diagram of Venn diagram of addition theorem. A minus B, A intersection B, B minus A. Mathematical statement of the theorem. For any two events A and B, the addition theorem states P of A union B is equal to P of A plus P of B minus P of A intersection B. P of A intersection B. Here, P of A intersection B denotes the probability that both events occur simultaneously. This adjustment is necessary to avoid double counting the overlap between events and A and B. Rules for addition probability. When the events are mutually exclusive, P of A union B is equal to P of A plus P of B. When the events are not mutually exclusive, P of A union B is equal to P of A plus P of B minus P of A intersection B. This is the two rules of addition probabilities. Case 1. Mutually exclusive event. Mutually exclusive events are that cannot occur at the same time. For such event, the addition theorem simplifies to P of A union B is equal to P of A plus P of B. This means that the probability of either event A or event B occurring is simple to sum of their probabilities. Mutually exclusive event A is equal to AB అంటే మ్యూచువల్లీ ఎక్స్క్లూజివ్ లో AB కామన్ ఉంటాయి. ఇండిపెండెంట్ లో AB రెండు కంబైన్ ఉంటాయి. Non-mutually exclusive event. Non-mutually exclusive event can occur simulation lead to on overlap. In this case, we have must subtract the probability of that intersection from the total. Thus, we use the full formula P of A union B is equal to P of A plus P of B minus P of A intersection B. Mutually exclusive events P of A or B is equal to P of A plus P of B. Non-mutually exclusive event P of A or B is equal to P of A plus P of B minus P of A intersection B. This is the formula of both exclusive events. Example of mutual exclusive event. Consider rolling a die. The events of rolling a 1 and rolling a 2 mutual exclusive. The probability of rolling A1 or A2 is calculated as P of 1 union 2 is equal to P of 1 plus P of 2 is equal to 1 by 6 plus 1 by 6. Hence, the probability of rolling either 1 or A2 is 1 by 3. This is the diagram. This is the pie chart are showing the this box shows about the mutual exclusive with the non-mutual exclusive. Example of non-mutual exclusive events. Suppose we draw a card from a stand deck. Let A be the event drawing a art and B be the event of drawing face card. The event A and B are not mutually exclusive since the king of hearts is both a art and face card. Therefore, we calculate P of A union B is equal to P of A plus P of B minus P of A intersection B is equal to 13 by 52 plus 2 by 52 minus 1 by 50 is equal to 24 by 52. Simplify to 12 by 26. 7 is this is the card art. This is the diagram of non-mutually exclusive events. Importance of addition theorem. The addition theorem simplifies the calculation of probabilities in complex scenarios. It is the foundation for understanding more advanced topics in probability and statistics. Mastery of this theorem is critical for application in fields such as finance engineering and data science. This is the diagram of Venn diagram. Limitation of theorem. The addition theorem applies specifically to discrete event, continuous event required different techniques. The theorem assumes that events A and B are actually defined and measurable. Ministerification of event can lead to incorrect probability calculation. This is the discrete line by line, continuous and graph law both. Conclusion and summary. The addition theorem is the key component in the study of probability and ifs calculate the likelihood of combined event. Understanding both mutual and non-mutual exclusive cases is essential for accurate probability assessment. Mastery of this theorem allows for the better decision making that prevents uncertainties. This presentation provides comprehension over the addition theorem. Thank you, madam, for giving this opportunity. Thank you.